Okay, so I'm back in my traces. I'm going to create another analysis report and new report. So this is going to be /recipe, HTTP method all, HTTP status all. Report name is going to be recipe page v2 versus v1 because we are going to compare the version 2 versus version 1 this time. Okay, so this is going to be pretty cool. The default module, so it's our default module, and the version 2, so this is the new version. I'm going to say last 24 hours, and I'm going to create a comparison with the default module, but with version 1. Okay, so let's hit submit and see what happens now. Okay, it's gone ahead and created this report for us, or it's creating it. Let's see when it finishes. Okay, it's running now. Okay, and it's finished. So let's go see what we have now. Okay, wow, what a big difference. Look, our current version is this blue area here, and the previous version is the orange area. See, with the previous version, we had this big increase in the response time here at the very end. So some 5% of our users, this is 4%, so some 5% of our users were getting some 3-second response time. And this is actually what we programmed, right? That bug was saying that 5% of the users are getting this 3-second sleep time. Okay, the new version now has this very quick response time, still at some, maybe some 20 milliseconds. Okay, so this is much better, and it doesn't have that spike at the very end. Okay, it closes off here, so there's very few requests that actually go over half a second. So the majority of our requests are being responded in between some, I'd say maybe 20 and 30 milliseconds. Okay, so this is fantastic. Now, why is there a small hump here at 30 milliseconds? I'm not entirely sure. We can go ahead and inspect this, but my intuition says that these requests here are not being fetched from the cache. Okay, and these are. Okay, so these requests are not being fetched by the cache, so it has to go to the data store and fetch the result, whereas these results are stored in the cache, and since the cache is much quicker than the data store, well, it responds back much quicker. Okay, so let's see also the cumulative distribution. Again, our graph is much better, so we don't have this peak at 3 seconds. We have the peak at 30 seconds, but as I suspect it's due to the caching. Okay, so here we can see the comparison also. So on average, we are taking 8% more in our 75th percentile, and we are taking 120% more in our 90th percentile, and this is true, right? So here we have this we're taking a little bit more here, and so the orange line is above the blue line here, but we're gaining so much more time in our 95th percentile that we see our fix work. Now, why didn't the orange line have this hump at the millisecond time? Well, this is because I was testing the application and I was throwing a lot of requests to my recipes, and I'm pretty sure that all of these previous tests that I was doing have made the application cache all of the requests that I sent when I actually did this report. Okay, so that's why I believe that there's no hump at the 30 millisecond. And since we updated the version of our application, well, the cache from version 1 cannot be used in the version 2. So the application went ahead and recached all of the requests, or it had to recache them. Okay, so let's go and see what's actually causing our requests to take a little bit longer in this case. Okay, so let's click on one request here, and immediately we see that we are trying to fetch something from the Memcache, but it doesn't find anything, so it has to retrieve it from the data store. So we get the data store.get, and again, it's not that dramatic. It's only 6 milliseconds to get something using the key from the data store. So this is also pretty fast, but since it needs to do all of these round trips, we also need to take in some network time. So these are these blank spaces here. And then it needs to add something to the Memcache. So once it gets the result from the data store, it puts it into Memcache so that the next time we fetch this, we're getting it from the Memcache. So that's why it takes a little bit longer. And this proves my theory that, it's actually that we're getting stuff from the Memcache. Let's go back and see one of the quicker requests. What is it doing? See, here it's only getting something from the Memcache. That's why it's much quicker. Okay, let's go ahead and actually do an experiment. Let's actually rerun this exact same request. Okay, so I've launched this request and I'm going to go to my logs and see if I find it. So I'm going to search for this request, okay, and I believe this is the one I just created, okay, so because it's the last one, and apparently it didn't get traced. So let's hit it again and see if we can, and let's hit the live play so that we can see if they update and see if it actually goes into the trace, because not all requests are being traced. It gets a random sample of the traces that are going to be traced, right? So again, this one didn't get traced. Let's hit refresh a couple of times to see if we get the trace of the request. Okay, great. So this one is being traced. Let's go into this one and see what's happening. Okay, and here we see that we are in fact getting it from the Memcache, and that's it. We're not accessing into the data store, because the previous trace that we looked at, we saw that it got it from the data store and saved it into Memcache. So now we just simply got it from the Memcache, and this is all transparent to us. NDB is doing all of this work for us. So it's optimizing our data store reads and writes. So this is amazing. Okay, so this about sums up or wraps up what I wanted to see in the Google Developers Console. And as you see, they have so many extremely powerful features here to debug our application and to actually profile our application and make sure that the performance of our application is really good.